Now that we understand the inequality symbols, let's try a problem with an inequality. I've written down the following problem. Negative 7k is less than 63. We're going to solve it like we would if there were an equal sign right here. So k is being multiplied by a negative 7. We're going to divide by negative 7 on both sides. Negative 7 divided by negative 7 is 1. We have 1k. I don't need to write the 1 in front of k because it's understood there's just 1k there. Since I multiplied or divided by a negative number, in fact I divided, I need to flip the inequality sign. And 63 divided by negative 7 is negative 9. K must be greater than negative 9. I can now graph this in order to test it as well. I draw a number line. I put 0 somewhere around the middle of that. And I place the negative 9 over here. If you want, you can have a 9 over here to make it nice and symmetrical. Now, I'm going to graph this by having an open circle right here because negative 9 is not part of the solution. That would have to be if it was equal to it. So I have an open dot. And it's going to be, get that nice open dot there, and it's going to be everything to the right because I need all the numbers that are greater than negative 9. So I can just make a nice thick colored line this way and place an arrowhead, meaning and everything to the right. So 0 should work, and 9 should work. Let's try a 0. Negative 7 times 0 is 0. 0 is certainly less than 63. Let's try 9. Negative 7 times 9 is negative 63. Negative 63 is definitely less than 63. You know, negative 5 would work in here. Negative 7 times negative 5 is a positive 35. That's certainly less than 63. But if I put in the negative 9, it should be exactly equal to 63, and that's why we're not going to accept it. Negative 9 times negative 7 is a positive 63, and that's not less than 63, it's equal to. And if I were to take negative 10, that's not going to work, because negative 7 times negative 10 is negative 70, positive 70, and positive 70 is definitely not less than 63. It's greater than. So this is the correct graph, and this is the correct answer. I know it's a little bit additional work, but it is worth plugging in some additional numbers and making sure you didn't make a mistake. These problems are usually so simple that mistakes are easy. Our next problem is basically what we call a conjunction or a compound. It is where you will have two things happening, this and that. Let's solve each one independent and look at what and means. First, on the left, I divide both sides by 2. I don't need to flip the inequality sign because I didn't multiply or divide by a negative. 2 goes into 2 once, so I have x, and negative 10 divided by 2 is a negative 5. On this side, I divide both sides by 9, and 9 divided by 9 is x, and that would be less than or equal to, and 18 divided by 9 is 2. Now I can graph them. I draw a number line. I put a 0 somewhere in the middle of that number line. The most important numbers here are negative 5 and 2. 5 is a little further away from the 0, and 2 is not as far from the 0, so I'm going to draw them like that. Then I'm going to look at this one. Negative 5 is not or equal to, so I have that open dot we spoke of. And x has to be greater than that. Well, all these numbers to the right are greater than. I'd rather have $10 instead of negative 5, so that's greater. Our next problem is basically what we call a conjunction or a compound. It is where you will have two things happening. This and that. Let's solve each one independent and look at what and means. First, on the left, I divide both sides by 2. I don't need to flip the inequality sign because I didn't multiply or divide by a negative. 2 goes into 2 once, so I have x. And negative 10 divided by 2 is a negative 5. On this side, I divide both sides by 9. And 9 divided by 9 is x, and that would be less than or equal to, and 18 divided by 9 is 2. Now I can graph them. I draw a number line. I put a 0 somewhere in the middle of that number line. The most important numbers here are negative 5 and 2. 5 is a little further away from the 0, and 2 is not as far from the 0, so I'm going to draw them like that. Then I'm going to look at this one. Negative 5 is not or equal to, so I have that open dot we spoke of. And x has to be greater than that. Well, all these numbers to the right are greater than. I'd rather have $10 instead of negative 5, so that's greater. So I'm going to be shading over to this way. I've got a fan going. So I'm going to be shading over to this way. At the same time, x has to be less than or equal to 2. When it's an or equal to, we use a solid dot, meaning that this answer is included. Negative 5 is not part of the solution, 2 is. And we need something less than 2, and less than goes to the left. And that's how our graph will look. And is always a connecting bar. It's between negative 5 and 2. 2 is included. So and is always going to have a graph that looks like this. We can also write a single, and this is the only time when we have an and equation, we can write a single compound statement. Remember my property of symmetry? I can flip these. Negative 5 is less than x. And therefore, negative 5 and 2 with x in the middle. You can do this with or, but it's really not considered to be proper form. So you'll never see an or written like this. Ors will go opposite directions, and we'll look at that next. But when you have a compound statement with and, we can write it with the x in the middle, the smallest to the left, the biggest to the right, and that represents our graph. You don't have to, but that's what the word and means, is we can put it in here. X is between here and here. Next we'll look at or. Okay, here's our or group of inequalities. Okay, here's our or group of inequalities. And we have 4x has to be less than 16, or 12x has to be greater than 144. Let's go ahead and solve these. I'll divide both sides by a 4. And that leaves me with x less than 16 divided by 4 is 4. Or I'm going to divide by 12 up here. 12 divided by 12 is just 1x. Greater than 144 divided by 12, which is 12. No need to flip any inequalities because we were not multiplying or dividing by a negative number. At this point, I'm going to graph this. I have a 0. 4 is about here, and 12 would be about there. Again, these are just basic inequality graphs. We're not going to use a ruler. So x has to be less than this 4. If I'm less than this 4, I'm going to have an open dot here because it's not an or equal to, and it's everything less than that, all the way to the left. Or x is greater than 12, not equal to it, so I use an open dot. So x is either less than 4 or it's greater than 12. Notice that they go opposite when it's an or. It's like the guy went that way or that way. Whereas an and, it was the part in between. He's between here and here. This is an or, so it's either that way or that way. Now, we never really write this as a compound statement. I've seen it done a few times. You're not supposed to, though. For example, if I were to flip this symmetrically, this would be 4 is greater than x. So you put a 4 here, an x here, a 12 here, and this symbol is like this and like this. That would be a compound or statement. It is really not what we call orthodox. It's not something you see in a book. It's not something we normally write. We normally only do that when it's an and. However, I've seen this done before. I won't do it, but I wanted to show you. The next thing we need to do is some more complex problems, and we're going to do those next. Here's a problem where we have a variable in between two inequality signs. And as I told you, that normally means it's an and. Our book and most teachers do not do ors this way. So we could probably expect an and. Now, when you have these additional systems or these numbers, what you want to do is what you do to one side, you do to the other. Well, that means what we do to one side, we need to do the other side, we need to do the other side. So let's solve this how you normally solve this with algebra, as if these were equal signs, which you wouldn't see because 11 doesn't equal 20 through the transitive property. So the first thing I'm going to do is I do reverse order of operations. What's the first thing you ever learned? Addition, subtraction. So what can I add or subtract to get y by itself? Well, I can subtract 2. So I'm going to subtract 2 from both sides. And then from the third side. 11 minus 2, that's a 9. 3y plus 2 minus 2, that just leaves me with 3y. And 20 minus 2 is 18. I subtracted. I didn't multiply or divide by a negative. So the inequality signs stay exactly the same. Now, I can't add or subtract anything else. Let's move up a level in order of operations. 3 is multiplying by 9. 3 is multiplying by y. So I need to divide all 3 sides by 3. 9 divided by 3 is a 3, and that's going to be less than 3 divided by 3 is 1, y. Less than, and 18 divided by 3 is 6. So 3 is less than y, and y is less than 6. And if I want to read it backwards, 6 is greater than y, and y will be greater than 3. Symmetrically, I can read it backwards. It's time to do graphing. 0's about here, 3 might be about here, 6 might be about here. If I want to graph this, I have no or equal to sign, so they have to all be open dots. So there'll be an open dot on the 3, an open dot on the 6. Y must be greater than that 3, but at the same time y must be less than that 6. And so you have the basic and view of a graph where you have that little bar in between. Y is between 3 and 6. Not equal to 6, not equal to 3. Now you can test this. Just use a 4, for example. 4, which would be right about here, 4 is greater than 3 and less than 6. But let's try 4 in the original equation. 3 times 4 is 12. 12 plus 2 is 14. And yes, 14 is greater than 11, and 11 is less than 14. 14 is less than 20, and 20 is greater than 14. So it certainly looks like we did pretty good. If we were to use 3, 3 times 3 is 9, plus 2 is 11. Yes, 11 is less than 20, but it's not greater to 11, it's exactly equal to. It's not a bad test if you want to see exactly where we bump up against what we call the limit. But it is good to test some things. You could test 0. 0 should not work. It's not in there. 3 times 0 is 0 plus 2. Well, that's 2. 2 may be less than 20, but it's not greater than 11. So this whole statement would be false. The whole thing has to work. So testing some other points does not hurt at all. We solved it, and then we graphed it. Let's try one more. Again, we have a variable between the two inequalities. This, the way your book works, the way most people work, represents an and. We don't usually write compound problems with or like this. Let's go with the order of operations. Addition, subtraction. Is there anything we can add or subtract? Leave z alone. Where there's this 1, we could easily subtract 1 from both sides. 36 minus 1 is 35. That's greater than or equal to negative 5 over, that's negative 35 greater than or equal to negative 5z, which will be greater than, and only greater than, negative 21 minus 1 more, that's a negative 22. The next thing is negative 5 is being multiplied by the z, so we want to divide by a negative 5. And we must do it on all 3 sections that are separated by the inequalities. Now 35 divided by negative 5 is a negative 7. And since we divided or multiplied by a negative, these inequality symbols need to flip. Negative 22 divided by a negative 5 is a positive 22/5. Negative 5 divided by negative 5 is 1, so that's z. So we end up with negative 7 less than or equal to z, which is less than 22/5. If 22/5 does not work for you in an improper fraction, if you don't like that, then 5 goes into 22 4 times. 4 times 5 is 20. 20 from 22 is left remainder of 2 waiting to be divided by 5. And so if that works better for you, then so be it. Improper numbers don't always work well for people. Sometimes we have to go to the mixed numbers so they make more sense. And we draw our graph, and we put in a 0. We're going to have a negative 7 over here. And if that's negative 7, then 4 2/5 is probably about here. This doesn't have to be super accurate. It's just a representation graphically. We need z to be greater than negative 7, reading it backwards. Negative 7 needs to be less than or equal to z. So since it's an or equal to, we'll have a solid dot. And z's got to be bigger than that. And we're going to have an open dot here. And I'm going to give it a little erasure just there so you can see it better. And z must be less than this. As I said, normally when we write these compounds, they're ands. And we have the little connecting rod. This means that 0 should work. So that's a good one just to try out. Negative 5 times 0 is 0, and 1 minus 0 is 1. 1 is certainly less than 36, and 36 is certainly greater than 1. 1 is certainly greater than a negative 21, and negative 21 is certainly less than 1. So that works. We could try a few other numbers. We can also try something outside. Now remember, this is an and. Let's try 5. That should not work. 1 minus 5 times 5, that's a negative 25. 1 minus 25 is negative 24. Negative 24 is not greater than negative 21. And since this is a compound, all of it has to work. Well, negative 24 is less than 36, and 36 is greater than negative 24, the right side didn't work. And since they're all chained together, the whole thing has to work. And that's why we normally only use these compounds for and, because an or, it can get a little messy. Well, this one certainly looks pretty good. The work looks good, and the graph looks good. Practice these. You'll get better at them.